Hello everyone, welcome back to my tutorial. In this tutorial we are going to solve this truss using Salome meca. So now just open the model, just open the Salome meca. Salome meca is the open source finite element analysis software which is having geometry model, mesh model and code aster. Code aster is a solver which is available, and Paraview for post processing. Now see the model. So this is the model. We have only one coordinate which is 7.5 meter length. Two coordinate we have, remaining coordinate we don't have. For that we'll use a shaper module to develop this model. So just go to shaper. Now we are in the shaper model. Go to sketch, create sketch. So we can choose plane, just rotate which plane you want to see. So I want to take XY plane for easy understanding. Choosing XY. Here you can see set plane view. So I'm in the plane view, just go here. So I'm going to create one line, straight line. So take a line from this 0 point. I'm starting it, first line. Just go here. There is one more, there is a simple triangle. This one, this is done. Then one more line I just want to create. From this here to, there is a point called C here and here. So this E, this is actually a midpoint. C is the midpoint. From we just want to connect here, and from 60 degree we just want to connect it here. So take this one, click here, connect it here, and there is one more line, take it here and connect it here. So this is our sketch. Make it fit screen. Now we'll set one by one. We'll set angle first. So there is an option called angle. So this angle is 60 degree and this angle is 30 degree, this angle is 60 degree. This one is 30 and this one is 60, and this one we need to specify the dimension of 7.5. So there is an option called horizontal length. This one 7.5. So this is getting collapsing. So this is half of the 7.5. So for that just take this one or 2 point, this point to this point, escape. We can remove this one, these two lines, delete it and delete it. Go to fit screen, just move this angle to here and move this angle to here. Go to fit screen again. This is, you just make it here for maximum view. Now just go to the picture. We just want to make a line. Here to somewhere here. Go to angle. This one is 60. Just see here, this one angle is 60. Now there is one more line we just want to make it. Just go to line from here to somewhere here. This angle we need to make. For that just go to angle. From this to this angle is 30. Just have a check. This is also 60. Go to angle, select this one, select this one. This one to this one. This is 30, but I just want to make that into 60. There is one more is there that has to be deleted. Select this one, delete it. See, now we have created the model. Now we can save this. Just complete. I completed the sketch. Now we can export this file. Go to File, Export to CAD format. Now we just want to choose it to Computer, Pictures, Code Aster, Trusses. This is the third model. I'm just naming Truss. Save. Now we need to choose this one. I have chosen. What it will do, it will create a surface and it will do. Now just tick this one. Now I have saved it as a BREF file. That means boundary representation file. Now I have done it. I can save this file. Go here, Vengat, Pictures, Code Aster, Trusses, third one, Study one. I'm just saving here. Now I have created the model. Now then I just go to Geometry Model, import the file here to create the groups. Go to Import BREF, Truss.BREF, save, open. See, we got the face file. So it will create a face. So from that we can export edges. Go to New Entity, Explode from edges, or we can explode into wire also. Wire, apply it close. See, first wire, second wire, third wire. So there are 3 wires we have. Now we'll build this wire. So go to Build Single Wire. So apply and close. Now see. So we have only one wire. So this is our model. We are done modifying our model. Now we can create the groups. So right click here, create group. First edge group, all the edges. This one is truss. Apply. Now just go to the problem. Here I want to fix it. Here I just want to give roller support. These 2 points I just want to apply a vertical force of 2.5 kN and 3 kN. So for easy understanding, what I'm going to do is, now just go to point, the first point, add, here, fix, apply. Now the second point, this is a roller support. I'm just giving roller, apply. Here just add. Here I just want to give force Y, the value of 2.5. Force Y to force Y1. This is a force Y1 I am giving. This is a force Y1, Y2. I just naming. Just apply it. Just add it. This is force Y2. Apply and close. Now see, I have created all the groups. Just go. So I have created all the groups. Now we'll mesh this model. Just go to meshing, wire, mesh, create mesh. Wire discretization. Here just choose local length of 0.3. Even number. Save OK. Apply and close. Now right click this mesh one, compute it. Now I have created 180 nodes, 120 edges. If you want to see these nodes, just go node. So this is the way I have created the mesh for our for my model. Just close this. Now just look. So these are node groups. This only one is edge group. Just save it. Now we'll go for code aster study to solve it. Go to aster study. Okay. Add a stage. Model. First read the mesh. This is my mesh format, MED format. Just apply it, save OK. Then go to model definition, assign finite element and model, finite element, everywhere, mechanic. Here we need to choose yes, we can choose Euler beam element or this Timoshenko beam element. I'm just using this. Just save, apply, save OK. Now model definition also done. We need to define element property. Go to Afikara element. This is a beam element. Section is rectangle. This is HY and HZ. Here 0.1. This is also 0.1. This is the section I'm commonly taking. We need to define the group. Go to edit, truss, save OK. Just save OK. Here there is a model. Just apply it, save OK. Now just go for material, define a material, linear isotropic. So Young's modulus is 210 e power 9 and Poisson ratio is 0.3. So this two property is enough. Save OK. Just apply it, save OK. Now it is done. Now just go for assign material. Mesh model. We can assign the material everywhere. Material, just save OK. Then apply it, save OK. So now we have created the material, we have assigned the material. Now functions are not required. Go to boundary condition, mechanical load. So this is a load. Now we just want to fix it. Just go here, this node I just want to apply fixed constraint. Here roller constraint, two forces I need to apply. One by one we'll apply it. First enforce degree of freedom. First one is group of node, edit. First I'm going to apply fix this node. You can see it here. Fix, save OK. We just want to fix it all the degree of freedom. 3 translation and 3 rotational degree of freedom. Make it 0. Now save OK. Now one more we need to apply it. Go to edit, node group, edit. There is an option called roller. Save OK. So see, make it axis visible. It has to translate in x direction. So remaining we will fix it. So keep this dx. Don't define dx. Define dy is fixed and dz is fixed. Now it is enough. Save OK. Now we have applied fixed condition here. Now we have roller support here we have given. Now we need to apply two forces here. The first force, the force y1 is 2.5, this node. Now you just scroll down here. There is an option called force options. Here these are all force options. There is an option called force nodally, means node. We can apply force in nodes. We can apply force in phase. So this thing we can use the force nodally. edit, group of nodes, force y1. See, this is the first one. Say OK. This is force in y direction. So how much is the force? 2.5 kilonewton in negative. So minus 2.5 kilonewton we can rate. So this is 2500. Say OK. There is a one more if we need to apply it. Just click this plus button, add it, group of nodes, edit, force y2, this node, save OK. This is actually 3 kilonewton, that means 3000 newton, 3000 in negative direction. Save OK. So now you see we have constraint, we have applied, forces we have applied. Here just make sure you have chosen model, say just apply it. Now this is the command it will generate at the back. Now just say OK. Now we have constraints we have given. Now just pre-analysis, leave it, go to analysis, meca static. So wrestling material you choose, everything we need to include into the analysis solver. Element property, model, here we need to choose loads. Go here, choose edit, load, choose it, save OK. Remaining thing we keep it same, just apply it, save OK. Solver we have defined. Now we need to choose post processing, calc champ. So in last case we have same name, we just want to give wrestling, constraint, first one EFGE Elno, then SIPO Elno, SIPO node. This is a directional stresses, bending stresses, everything it will come in SIPO Elno node. This Elno means element. This is node. Then we just scroll down here, there is one more option called forces. There is a reaction nodal, this has to be chosen. Now it is enough. So result you took wrestling, model, material, element property. So switch it on that. Now just apply it, save OK. Now we have done everything. Now we just want to save the file in RMD format, output format, to view the result in Paraview. Set output results. Just click this 3 dots. Now save the file in the locations. This is my third case. Result.rmd. Any name we can give, but without space. Just go to results, edit, mesh. Here you have to choose calc champ. Go to element property. There is an option called tau champ. You just make it yes. Now scroll down, just save OK. Make this MED format on, just apply it, save OK. Now we have defined everything. Now just save this file. Now we can solve this file. Go to history view, save, click this one, make this 5 seconds, run it. If you are doing nonlinear analysis, we can see the graph how every iteration is getting converging. So this is a message file. Just scroll down here. It is solved without any error. If any error comes, it will show here. Now we can view the folder also. Just go to pictures, code aster, trusses. Third case, this is a study file. In this folder, run case is the first case. Result stages, open it. These are the file, mesh file, command file, message file, export file, log file, everything it will save here. This is a script file to solve it. Similarly, to see the results, it will save it in the outside, very closer to the study one files. So now we can open this result file in Paraview to view the results. Now just go to Paraview, open, Third case, result, say OK, apply, displacement. So this is the displacement plot. If you want to see reaction forces, this is the reaction force plot. If you want to see stress, normal stress, bending stress, these two are bending stress in X, Y. These two are shear stresses. This is torsional stress. So this is a normal stress. So now we can see the displacement. So we are applying two forces. So we just go for plot. If you want to see it in a plot, we are already seeing the plot. To change the color, so this is the plot. So displacement is maximum here because we are applying a force here in vertical direction. It's getting deforming. So maximum displacement is 3.2 e for minus 5. So change this into dx. This is dy. Here it's getting deformation more, 1.6 e power minus 5. Here also the next here. If you want to see the nodal value, what value we are getting exactly. So there is an option here, selection display inspector. If it is not getting here, just go to views, windows, switch on this selection display inspector. So after switching on here, now just go for selection, select this particular point, and here you just go here, choose the displacement. The first one is dx, dy, dz. This is the first one. So 1, 2, 3, 4, 5. So 1.6 e for minus 5 we are getting here. If you want to value here also, just select it here. If you want to add nodes very closer to that, we can add it like this. We can zoom it, how the displacements are changing. Here the displacement in x direction is 0.000011, 0.000010, like that it's decreasing displacements. So we can close this one. Now if you want to see the stress, go for this one, normal stress. Fit screen, just give fit screen. Change this color into blue to red. Apply close. This is to view clearly, that's why this color will looks good. Normal stress. If you want to see the stress value, any one of the member, we can see these are negative, means compressive stress. Here we are applying the force, it's rolling, it's getting compressive stress. This red color member is getting tensile stress. If you want to see the stress value, just go switch on this one. Now we can select the point. So this point, you see, this is red color tensile stress. If you want to see this point, these are getting compressive stress. And this member, if you want to see this member, this is a tensile stress. So sigma n is a sigma x. See, if you want to see in CalcChamp, see, we are seeing the SIPO node. So Sn is nothing but, you see, normal stress, sigma xx. Sm Fy is nothing but a bending stress about y-axis. This is a bending stress about z-axis. You see, this is a normal stress along the member. So sigma x. So this is a normal stress. This is a bending stress about x-axis. The bending stress about y-axis is 0. So one by one we can have a look. 1, 2, 3. There are six values. First value, second value, third value is 0, fourth is 0, fifth is 0, sixth bending about. This is a torsional stress, it's rotating. This is a torsional stress. Okay, like this we can check. So in that we have completed the stress analysis of truss using code aster. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.